Okay, so here we are taking a look at the test that we took last week, trying to go through step by step and spend a little more time on the more difficult problems. We'll try and get through the first page in one video. So, I'm sitting here with Steven. Say hi, Steven.
Hi.
So if he has questions, he's going to ask while we go through it. And I want you to speak up. If I write something down that you don't understand, then you're going to say, I don't understand that. And if it takes us longer, it's okay. All right, so the first question involves a change in temperature. And a change in temperature tells us that you're going to need to use the equation that has change in temperature in it.
Mm-hmm.
So you probably remember that Q is measured in joules and represents heat. M is in mass, or is measured in grams and represents mass. The CP is measured in joules over gram degrees C. So when you see this stuff all together, like right here, that is specific heat capacity. And the delta T, this little Greek letter is called delta. That means change in temperature.
Okay.
So change in temperature, and that's measured in degrees C. So since we have a degrees temperature change, then we're going to use the equation that has temperature change in it. So we go ahead and write the equation down. Q equals M CP delta T. So what do we know? Well, we know the specific heat of aluminum is 0.90. Notice how it has 0.90 joules per gram degree C. So that means it's 0.90 joules over GC. And that's all one thing.
Mm-hmm.
How much energy is required? So that means how much energy is measured in joules. So this is Q. Oops, sometimes that happens. So this means how much energy. All right, so how much energy means how many joules, we're looking for Q, is required to raise the temperature of 10 grams. So 10 grams, well, that'd be mass, wouldn't it?
Yes.
And then from 10 degrees to 25 degrees, so how far is it from 10 to 25?
15.
It'd be a 15-degree change. And so there you have the math that's necessary to figure this out. So I'll reach to the side and grab a calculator. And it looks like our answer would be 10 times 0.9 times 15. So the answer to that first question would have been 135. The 135 is just in joules. The reason for that is C's cancel, G's cancel, and I end up with just plain old J. So that's how you handle the first problem.
Okay.
The second problem, you've got a 100-gram sample of metal. It's undergoing a temperature change. Keywords, temperature change. And you're going from 10 to 50. So what is the temperature change from 10 to 50? Let's just figure that out real quick. What is it?
40.
That'd be 40. Okay, it says you're absorbing 1,500 joules. Which one of these variables is 1,500 joules going to fit? Is that Q, M, CP, or delta T?
It will be M. No. CP.
CP has joules over GC, and this is 1,500 joules, right?
Right.
So isn't that just plain joules right here?
Right.
That's supposed to be a J up there. Maybe that's not real clear either. All right, so there you go. That's J. So this number here is the number of joules.
Okay.
Okay, so let's go ahead and write the equation down. Q equals M CP delta T. Okay, what was Q again?
1,500.
Yep, 1,500 joules. The M
It was 100 grams.
is 100 grams. We're looking to find the CP because it says what is the specific heat of the metal right here.
Right.
So I'm just going to call that X because we don't know what it is. The change in temperature is,
Yes.
you already told me, it's 40. Oh, oops, that was not supposed to be that. All right, degrees C. Okay, so now we need to do the math involved with solving for X. So 100 times 40 is 4,000. No units cancel when I multiply those, so I'm just going to call it G degrees C.
Okay.
And that will be multiplied by X. We don't know what X is, remember?
Right.
On this side, we still have the 1,500 joules. So now we're ready to solve for X. How do we do that?
Oh, with the divide. from
Yeah, we
both
divide
sides.
both sides. So we're going to divide both sides by the number that is with the variable. So
Right.
the number that's with the variable, is that to 1,500 or is that to 4,000?
1,500.
No.
4,000.
And that's a common mistake, boys and girls. You want to divide by the number that's with the letter you're trying to find.
Okay.
So you're trying to find x. So you got to get rid of everything that's with the x. So you're going to need to divide both sides by what?
4,000.
By the 4,000. Man, sorry about that. Okay, so divide by 4. I don't know what I'm doing there. That's it. Did I erase anything? No. Okay, so divide both sides by 4,000. And that'll just be GC. Divided by 4,000 GC. So everything over here cancels except for x.
Mm-hmm.
So I'm going to go ahead and put this answer down. 1,500 divided by 4,000. It's also very common for students to go 4,000 divided by 1,500. But the number you put in the calculator first is the top number. So 1,500 divided by 4,000. So the answer is 0.375. Since no units cancel, you just leave them all in there. Joules over GC. Which is good because that matches what I told you the heat capacity was supposed to be
Right.
measured in.
Mm-hmm.
All right, so that's the end of number 2. Number 3. You're going to raise the temperature of 30 grams of water
Mm-hmm.
by 50 degrees. So is that a temperature change problem? You're going to raise the temperature by 50 degrees.
Yes, that's temperature.
Yeah, that's temperature change. So you're going to need to use that same formula. Q equals M CP delta T. And we're looking for how many joules. So which variable are we trying to solve for? How many joules? Which would that be?
Q.
Yeah. So we don't know Q. But we do know mass. What's the mass?
It's 30 grams.
Yeah, 30 grams. CP is not in the problem, but since it does tell us that it's water, at the top of the page I had given you the heat capacity of water.
Right.
So that was 4.18. Oops. And that's joules over gram degree C. And what was the change in temperature again?
It's 50.
Yeah, 50. Because it just says you're going to raise it by 50, so you don't even have to subtract this time, because
Right.
it just tells you what you're going to raise it by.
Okay.
So you multiply those three numbers together, you get 30 times 4.18 times 50. Answer 6,270. All right, so that's the answer to that one. All right, now 4, 5, and 6 deal with regions of this graph that don't involve a temperature change.
Okay.
So you know the graph starts below freezing, it melts, and then it goes up to boiling, and then things boil, and they continue to get hotter.
Mm-hmm.
This temperature right here, oops, don't want to do that. This temperature right here is 0, and this temperature up here is 100. That's freezing and boiling. So since we're at 0, we're down here, right? So when you're at 0 degrees, oh, I'm skipping down, aren't you? I'm sorry, I'm going to go back to number 4. In this one, we're doing 10 grams of water at its boiling point. At its boiling point, that'd be up here, wouldn't it? At
Right.
the top?
Mm-hmm.
Okay, so there's no temperature change mentioned. And that's because at the boiling point, the temperature doesn't change. It just stays the same. Remember we did the ice experiment where we melted the ice and heated it until it started to boil, and then it never
Yeah.
stopped boiling. Okay, so this is the formula that you use at the boiling point. It's up here. So Q is equal to M times HV. Well, we know mass. What is it?
It's 10 grams.
And the HV is given to you at the top of the page. 2,260 joules per gram.
But we don't know how many grams is it. I mean, how many joules.
We don't, but we can find it by multiplying.
Right.
So 10 times that, that gives us 22,600. Since grams multiplied by J over G would cancel out the grams, just like moles used to cancel out,
Right.
you'd have joules left in your answer, and that's your final answer.
Okay.
And number 5 and 6 are similar. 5 is at 0 degrees, so that's down here. So the formula that you're going to use would be the formula that applies for freezing. Remember this one was for melting or freezing,
Yes.
and this one was for boiling or condensing. All right. So down here we're at freezing, so you're going to use the one for freezing. Q is equal to MHF. What's M?
Oh, 25 grams.
Yeah. And the heat of fusion, we look up at the top of the page, and you got a blank one here. The heat of fusion is right here, it's 334. Right there. All right, so we multiply that by 334. And 25 multiplied by 334 is 8,350 grams. Oh, excuse me, joules, not grams, because grams cancel. So that's the joules.
Okay.
All right, then the last one on the first page, you're at 100 degrees again, so it's like the boiling point, so you're up here, right?
Mm-hmm.
So which formula do you use? This one or this one?
We use the first one.
Yeah, the HV formula. So we'd have Q equals M HV. What's this 100 degrees we're not going to use here? All that does is tell us that we're at the boiling point.
Right.
But we do need to use this number. Which variable is that?
That is for Q.
Yeah, so we'd have 565 joules. We're looking for how many grams. So
Right.
that'd be M. We don't know what that is. HV, I think we know, don't we?
Oh, it's 2,260.
Yes, it's 2,260. All right, so now what do we do to solve for M?
Oh, we multiply.
Do we multiply? Or do we,
Oh,
yeah, because see, you're trying to solve for this variable, aren't you?
yeah.
So what are you going to do?
Divide.
By? Would you divide by the 20? Yeah, there you go.
2,260.
Because you divide by the number that's with the variable you want to isolate.
Okay.
All right, so what happens when you divide this by this, you get 0.25. When you divide joules by joules per gram, that's like joules over joules per gram. It's a fraction, so it's like joules over 1 divided by joules per gram. So you end up with joules over 1 times grams over joules. You multiply by the reciprocal when you
Mhm.
multiply fractions, or divide fractions. So when you divide fractions, you multiply by the reciprocal. Notice that joules cancel. You end up with grams over 1, which is just grams. So the unit on that is grams. There we have it. That was page 1 on the test.